Good morning to all. Today again I am going to discuss about dual nature of radiation and matter. In that case, I am just concentrating about de Broglie wavelength. There is a lot of problem and old question paper problems. I have concentrated more over here. Just going to discuss about de Broglie problems on this session. Problem here. The ratio of velocity of proton and alpha particle is 4 is to 1. See what are the things they have given? Proton alpha particle is 4 is to 1. The ratio of the de Broglie wavelength will be. Already you know this one, you have heard about this one, de Broglie wavelength. De Broglie wavelength here is lambda is equal to h divided by p. Now this is usually we know this formula, lambda is equal to h by p. From here, P is about momentum. Momentum here is mass into velocity. Now you just substitute the value of P in that equation. So lambda is equal to h divided by m into v. Now, see, they have given two particle. One is proton, one is alpha particle. Proton symbol here is 1h1 and the alpha particle symbol here is 2he4. See, from this one, what are the things they have given here is, first you just mention here what is the charge, what is the mass of the particle, what is the velocity. See, they have given the velocity here is v1 is to v2. That one v1 is to v2 will be equal to 4 is to 1. See, similar here for this one, for example, for proton, I just mentioned here, charge is 1, mass of the proton here is 1, and the velocity here is 4. For helium 2He4, mass here, charge here is 2, and mass here is, mass is about your atomic, this one. See here, your mass number, charge is about to atomic number, and the velocity ratios they are given. From this, I just mentioned here, lambda is equal to h divided by mv. Similar concept, lambda 1 divided by, I'm sorry, this one here is lambda 1. Now, lambda 1 divided by lambda 2. Lambda 1 divided by lambda 2 here is h is Planck constant, so h divided by m1 v1 whole divided by h divided by m2 v2. Planck constants will be the same, so that what you are having here is m2 v2 divided by m1 v1. See, from here m2 mass and all, you know, you just substitute the values here. So 4 is to 1 and here is 1 by 4. So what you are going to have here is 1 is to 1. So answer in this case here is, which of the following figure represents the variation of a particle momentum and associated with the de Broglie wavelength? See, in all the cases, wavelength has been given along x-axis and the momentum has been given along y-axis here. See, here, what I'm going to mention here is same concept in case of de Broglie wavelength. See here, de Broglie wavelength. That formula I just mentioned here, I'm going to mention about formula lambda is equal to, still now we have seen, see till the end we are going to see the same formula, lambda is equal to h divided by p, and directly they are mentioned here. The h is about Planck constant. From this one, lambda is proportional to 1 by p. Now see here, as p value which goes on increases, this is about denominator, so that lambda value will be keep on decreases. Now, or else you just consider in that case x-axis, the known value should be taken along x-axis. Similar concept, see, lambda is proportional to p. Now see here, in all the cases, x has been taken as an x-axis. See here, as x-axis goes on increases in that way. As x-axis, here lambda values goes on increases. If lambda is goes on increases, what about p value? P value which should be decreased because both are inversely related. See, this one you can understand here. This one As a lambda value increases, p value will decreases. So this one option will be there. As lambda increases, p value is not decreasing, it gradually increases. And this is a straight relation. As lambda increases, see here, as lambda increases, p value also increases. This is directly related, and this one is inversely related. Whether this one or this one should be there. For in this case, I'm going to mention this one from here, lambda into p. See, what I'm going to mention here is lambda into p. That one already we mentioned here, that is a Planck constant, that we call it as constant here. So this one will represents the general, say, x into y will be equal to constant. So this one will represents about a rectangular rectangular hyperbola. See a rectangular uh, hyperbola. See, hyperbola in this case. So how you are going to have here is, I just draw and show you over here. See, rectangular hyperbola in this case. See here, if this is along the x-axis and y-axis over here, so all the hyperbola conditions will be like this. So this is about the rectangular hyperbola in this condition. We are going to have this conditions over here. So answer in this case. But another one thing, why it is not this one? This is a straight line equation. That is a y equal to mx plus c. That's concept. This is straight line equation. So you are not going to have. See, this is xy equal to constant. This is a rectangular hyperbola. Have to understand the concept between these two so that you can easily understand it. Problem. The graph, similar like the previous one, the graph between de Broglie wavelength lambda and lambda p. And here additional value what they are given, p is a linear momentum. Linear momentum means it is a variant changer. See, in this case, x-axis lambda value they have given and y-axis here is lambda p. So now, so what I'm going to do, I just show you again the same de Broglie wavelength lambda is equal to h divided by p, or even lambda p, that one will be equal to constant. See, from this case, as lambda value increases, similarly p value will also increases, and even p is the linear momentum. So which has been similar like a linear equation. See, as in this case we can see, as lambda value increases, p value will also increases. That is about linear in this case. But here only they are mentioned, only momentum has been a linear. So in that case, what I'm mentioning here is lambda p equal to constant. So that what you are going to have here is, as lambda value is keep on increases, lambda value increases, at the same time p value also will be increases, so that that one will be equal to constant. So lambda p will be equal to constant. So in this case, as lambda increases, see, again I just mentioned here, as lambda value increases, at the same time lambda p value will also increases linearly. So answer in this case here is, this is little important and concept oriented. Concept oriented, you just concentrate here. The wavelength of an electron, they are asking about the wavelength of electron will be of energy of 100 electron volt. That means if the electrons are accelerated with the energy of 100 electron volt, then what it will be that wavelength. So they are asking about the wavelength. See, in this case, see here, for this one, this is about the charge of the particle. See, you can understand here. For example, in case of electron, Q is a charge, M is about a mass, and it can be accelerated with a potential of this one P. So in that case, what they have given here is lambda. For case of electron, here is lambda is equal to 12.27 divided by square root of V angstrom, or how this formula came. See, for that they have mentioned here, the previous one we can see, actually this formula is derived from this equation, that is 2mq into v. See, for this one I just mentioned all the value. H value here is 6.624 into 10 to the power minus 34. You just mentioned here 10 power minus 34, and square root of, I just mentioned here, 2 into 2 into mass of electron here is 9.11 into 10 power minus 31 into, and charge here is 1.6 into 10 power minus 19, okay, into V. Now this one, from this you can understand here. So if you multiply this one, cancel this from here, see, multiply this one all the values and cancel it, so that what you are going to have here is this formula. From this one, now what I am going to do here is, from lambda is equal to, now I substitute the value here, lambda is equal to 12.27 divided by 100 electron volt they have given, so 100. So what you are going to have here is 12.27 divided by square root of 100 here is 10. So 1.23 wavelength here is angstrom. So answer in this case, this question here is old question paper question. See here, if the kinetic energy of the particle, first one, kinetic energy of the particle is increased for 4 times, then the percentage decrease in de Broglie wavelength. See, electron kinetic energy has been increased for 4 times. So what is the percentage decrease? Already they have mentioned percentage will be decreases in case of, see here, already they have given de Broglie wavelength lambda and kinetic energy both are inversely related. As kinetic energy increases, de Broglie wavelength is decreases. Right, see this one. Now I just mentioned here, according to de Broglie wavelength, you can understand here lambda is equal to H divided by P. Now, this one, wavelength and kinetic energy, how we can relate over here. For this to understand, I just mentioned here, kinetic energy K is equal to 1 by 2 m v square. This one I just multiply m by m. So this one, if you cancel here, this one will be equal to 1. So I just mentioned as m square v square divided by 2m. So that one will be equal to, so K is equal to m square v square divided by 2m. M square v square here is momentum P. P square is equal to 2m. So P square, or even P square equal to 2mk. From here P is equal to square root of 2mk. See this one, from here lambda is equal to h divided by square root of 2mk. Already they have mentioned lambda is inversely proportional to square root of k here. Now from this one, now you just mention here, in this case what is lambda here, I just mention as this one, lambda is equal to h divided by 2mk. Next one, if kinetic energy has been increased, what about lambda? So that I just mentioned as lambda dash. Kinetic energy has been increased for 4 times. So that 2 square root of 2 m into, what you are going to mention here is, it's going to increases for 4 times 4k. So that what you are going to have here is h divided by 4. If you take this one, 2 square root of 2m k. Now h divided by this one here is lambda divided by 2. See from here, so from here what you can understand the relationship between changing kinetic energies to the wavelength here is, wavelength has been reduced into half. Half means that is 50 percentage. How you can mention this one? See here, this one I just mentioned as a percentage decrease. Percentage decrease here is 1 minus lambda dash divided by lambda into 100 percentage. Now lambda dash value here is already we found, lambda by 2 divided by lambda into 100 percentage. Now from this one, lambda will be cancelled here. So this one here is 1 by 2 into 100 percentage. So what you are going to have here is 50 percentage. So answer in this case, interesting problem here. See, a particle in is projected horizontally. See, suppose if you consider a particle which is projected horizontally like this. So that what happened here is, while it's moving same fast, which is not relevant to the gravitation, so that it will be moving in a straight line. But because of the influence of gravity, what happened, it will attain a projectile motion. So that's what they have mentioned, a particle is projected horizontally with velocity 10 meters per second. What will be the ratio of de Broglie wavelength? See, one concept, de Broglie wavelength of the particle when the velocity makes an angle 30 degrees, 60 degrees. So two variant they have given. One is about what about the de Broglie wavelength at different angles. So we have to find out the relationship between the de Broglie wavelength and the different angle, so that we can easily find out. See here, see I just show you. If see from this one, if the particle is projected horizontally towards this direction with the initial velocity u, right? So it's moving with velocity, that is v is equal to 10 meter per second. They have given here. This is about the resultant velocity v, that is 10 meter per second. This is having a two coordinates. One is about x-axis coordinate. Another one is about y-axis coordinate. Here vx and vy. Here v is about a resultant vector or even the resultant velocity. See for this one. See here, this is x-axis. I just put a line over here. This is about again Vy. See, this is Vy. For this case, what I am going to do, first I just going to find out what is cos theta component. Say for example, cos theta will be equal to, cos theta here is adjacent side by hypotenuse. Adjacent side here is Vx and hypotenuse here is V. That is a resultant vector, right? See from this one, U divided by V. From here, what I am going to mention, V is equal to U divided by cos theta. See from this one, u will go there, cos theta will come. Sorry, v will go there, cos theta will come. From here, what I'm going to mention, v is proportional to 1 by cos theta, as u is the constant initial velocity. So v is equal to 1 by cos theta. Next one, de Broglie wavelength. So lambda is equal to, what you are having here is h divided by p. That is h divided by m into v. Now, from this case, the same one, lambda, it's mainly depends on not about the mass. Mass is not going to change. At the same time, Planck constant is not going to change. See here, only changes here is h and m is not going to change. Only changes here is about velocity of the particle. So that what I mentioned here is lambda is inversely proportional to 1 divided by v. See here, this is equation number 2. From equation 1 and 2, see here, from equation 1 and 2, what I'm going to mention here is, see from this one, lambda, what is proportional to here, lambda is proportional to 1 divided by v, and you just substitute the value of v, 1 divided by 1 by cos theta. So that lambda is proportional to what now, lambda is proportional to cos theta. Again, lambda 1 is proportional to cos theta 1, lambda 2 is proportional to cos theta 2. From here, lambda 1 by lambda 2. That's what they have asked the ratio here. That is cos theta 1 divided by cos theta 2. Cos theta 1 they have given as 30 degree. Cos theta 2 they have given as 60 degree. Cos 60 is 1 by 2. Cos 30 is root 3 by 2. 2 will be cancelled here. So what you are having here is root 3 is to 1. So answer in this case here is root 3 is to 1. Next question here is, the positron, that is small m, proton capital M, are accelerated by the same accelerating potential. See, both in this case, both are accelerated by same accelerating potential. Then the ratio of the associated wavelength of uh, positron and proton will be. Now in that case, let me tell you here. See, for example, in this case, what is the main key point, the key difference between the positron and proton here is, see, both are, first one is, both are having positive charge, and here only the main difference here is the proton, which is having more mass when compared to the positron. Both are positive, but at the same time, proton, which is 2000 times greater than the positron here, and at the same time, both are accelerated with the same potential. In that case, both positron and proton acquire same kinetic energy because both are having a same mass. So kinetic energy is equal to half mv square. So mass will be the similar in this case. Kinetic energy also similar. So that what I'm going to mention here is kinetic energy will be equal to the applied electric potential. See, I just mentioned here kinetic energy will be equal to the applied electric potential that I can mention as E into V. Now, another one already we have seen the previous problem only. What is the relationship between the wavelength and to the kinetic energy? See here, lambda, that one will be equal to that one h divided by p, and we have substitute the values, that is h divided by square root of 2m into k. See, in that case, see lambda of proton, I just mentioned this one, lambda of proton will be equal to h divided by square root of 2 and mass of proton and even kinetic energy, because kinetic energy is same. And lambda of positron I just mentioned here, h divided by square root of 2m. Positron I just mentioned as pi into k. Now from this one you just find out the ratio between uh, wavelength of proton to the wavelength of positron. Proton will be like h divided by square root of 2mp of k, and whole divided by h divided by square root of 2m pi of k. See here common term will be cancelled here, h will be cancelled, and the square root of 2k will be cancelled here. See from this one what you are going to have here is mass of pi to the mass of proton. See, mass of proton and mass of positron they have given. Positron here is small m and proton here is capital M. So I just mentioned here from this one, proton here is what you have, positron here is small m and proton here is capital M. So the answer in this case, see here what you are going to have, this is a root of square root of. So what you are going to have here is square root of small m to the square root of capital M. So answer in this case small m divided by capital M. The small changes here is what they have given, the ratio associated with the wavelength of positron to the proton. See, wavelength associated with proton to positron here. So proton to positron square root of small m by capital M. But positron to proton in this case, you have to mention this one, but I didn't tell that one. I just add this one again. So ratio of positron to wavelength ratio of proton here is square root of capital M divided by small m. So that is that answer I have specified in this one. Problem. See here, if velocity of the particle, see velocity of a particle is 3 times than that of electron. So particle which is 3 times greater than electron. That means if velocity is more means mass will be little less. You just remember this one. Next one, and the ratio of a de Broglie wavelength of a particles to the electron. See, particle to the electron they have given the value. Then what type of particle is this? That's what they have asked here. See, for this one I just mentioned here de Broglie wavelength here is lambda is equal to, I just mentioned again, lambda will be equal to h divided by p. Now from this one h is about constancy, lambda is equal to h divided by m into v. In that case, so for example lambda of particle I just mentioned as lambda is equal to particle p, here is a constant, here is h, mass of particle and the velocity of the particle. Similar case, lambda of electron I just mentioned here, that is h divided by mass of electron and velocity of electron. And now see, I just mentioned here what they have given, wavelength of particle to the wavelength of electron ratio. So from here h and h will be cancelled here. So what you are having here is mass of electron and velocity of electron. See, I didn't put all the steps here. I just shortcut this one. You just find out this one. Mass of proton and velocity of proton. See, from this one, the ratio what they have given here is 1.81. 4 into 10 to the power minus 4. That one will be equal to mass of electron here is 9.1 or 9.11 into 10 power minus 31, and the velocity of electron I just mentioned here divided by mass of particle I just mentioned as mp into 3 times that mass of velocity of particle here is 3 times the velocity of electron. So 3 will be cancelled here. From this one, what I am going to mention here is mass of proton will be equal to, see here, this is 9.1 into 10 power minus 31 whole divided by remaining what is there, 3 is there, and this one 1.8 into 10 to the power minus 4 is there. Now you just cancel this one. If you consider this is 9 and this is 1.8, here is 0.2. So I just mention as uh, 1 divided by 0.6. You just multiply here, 0.2 into 3 here, 0.6, and if you cancel this one, 10 to the power of 4 will go, that will become 27, right? 1 by zero point 0.6 here is, this will be approximately 1.67. You just put remember this one, multiply and divided by 10 here. So 1 divided by zero point 0.6 here is 10 by 10. So what you are having here is 10 by 6. 10 by 6 is 1.67 into 10 power minus 27 kg. So this is approximately equal to the mass of neutron. So this is about mass of neutron. So that particle is neutron. Next problem. The de Broglie wavelength of a neutron in thermal equilibrium with a matter having average kinetic energy. So they have given average kinetic energy. This Kb is nothing but a Boltzmann constant at a 300 Kelvin. See here, Boltzmann constant value I just mentioned here. So usually they will give you as a hint, or otherwise even they will give you that Boltzmann constant value and all at the last page. But you need to remember this one. If they haven't given that one, some of the concept and the constants and all, you need to remember. This one here is Boltzmann constant here is 1.38 into 10 power minus 23, and even Planck constant, that and all, even a mass of the proton, electron, that and all you need to remember here. So according to this de Broglie wavelength here is lambda will be equal to, so lambda here is h divided by p, that one will be equal to h divided by square root of 2m k. K here is kinetic energy. Now substitute the value here. So h divided by, already they have given the kinetic energy value 2m into kinetic energy here is 3 by 2. This is Boltzmann constant. Remember, Kb is Boltzmann constant. This K is kinetic energy. Now from this one, 2 will be cancelled here. Now you just mention here h divided by square root of 2 into 3. Again I just mentioned as this one 2 is cancelled here, so only you are having 3 is there. 3 into mass here is 1.67, so 1.67 into 10 power minus 27 kg, and into next one is about a Boltzmann constant, that is 1.38 into 10 power minus 23 here, and even that is multiplied with they have given temperature value, that is in Kelvin. You have to substitute this one in Kelvin. So if they have given in degree Celsius, you need to convert this one, and H value also I just mentioned here, 6.624 into 10 power minus 34. Now substitute this value. Now all this value you just cancel it, and what you are going to have here is, you just try the steps. If you couldn't get this one, you just pass a comment on this one. I will um, I will explain that one separately. So depends on your doubt. You just ask me, I will tell you. So here the answer here is 1.45 into 10 power minus 10 meter. That is 1.45 angstrom. angstrom. So answer in this case is this one. This is a little important. This questions they have asked in a competitive exam. See here, light of wavelength 500 nanometer is incident on a metal surface. Work function here is 2.28 electron volt. The de Broglie wavelength of emitted electron. So it will be little like a confused, but it's not confused. You just consider here. See, light wavelength one, see, I just mentioned here a simple, I just mentioned, I just put a diagram over here. See, this is the metal surface. Now light is incident over here, see, on the metal surface. So what happened here is, because of the work function, electron is emitted out. Electron is one of photon just mentioned here. This is a light photon and the electron is emitted out with the help of this work function. They have given the work functions here. Now see this one. In this case, see here. So what they have mentioned here is, see, if depends on the frequency and the wavelength of your incident. This one, frequency and wavelength of your incident electron or incident photon that emits a electron over here. So depends on this one electron which is coming out with the fast moving, so that its kinetic energy also increases. So already we know this one. What is the relationship between the kinetic energy and de Broglie wavelength? Here is lambda is equal to h divided by square root of 2mk. See, first what you are going to do here is relationship between the wavelengths to the kinetic energy. Now you are going to substitute this one. See, from this one, with the help of a work function, you are going to find out the kinetic energy. Now you are going to substitute the kinetic energy formula over here, so that you can easily find out the wavelength, the de Broglie wavelength of the emitted one. See, I just mentioned here. First one, in that case, see, emitted electron which is having a kinetic energy, I just mentioned as kinetic energy maximum will be equal to, so hc divided by lambda minus of this one work function they have given as a work function. Now from this one, see, hc already you know this one, 6.624 into 10 power minus 34 here, and 3 into 10 to the power 8, and divided by lambda. What's that value they have given? That is 500 nanometer. Nano means 10 power minus 9 meter here. And see here, kinetic energy what you are getting, that is in joule. So if you want to convert this one, that is in electron volt. So once you are going to confirm this one in electron volt here is, you can mention this one 1.6 into 10 power minus 19, and minus already that pi value what you are going to give here is work function value here is 2.28. Now you just cancel this steps and all, you just cancel it. If you are having a doubt, you just specify your doubt. I will tell you, I will explain separately. Now because a short period of time, I just write down here. So if you cancel this one, cancel the steps, what you are going to have here is 2.48 electron volt minus 2.28. So from this one, what you are going to have here is the kinetic energy in this case here is 0.2 electron volt. So answer for kinetic energy you got here. Now you are going to use this relation, that is about lambda. See here, as kinetic energy increases, what about lambda? Lambda will be decreased. So lambda minimum, that one will be equal to h divided by square root of 2, see, I just mentioned here, 2 m and k maximum. That's what we found out here. Now substitute this value. Already you know this one, 6.624 into 6.624 into 10 power minus 34 and divided by square root of 2 into, and this one here is mass of electron. I just mentioned here, mass of electron here is 9 into 10 power minus 31 into k maximum that we found out here, that is 0.2 electron volt. So electron volt in this case, what you have to mention again, 1.6 into 10 power minus 34. Suppose see here, in this case 10 power minus 34 here. Suppose in this case, if you are not going to convert this one, this will not, even this one you have to convert. So no need, you just need to convert everything. Now you just simplify this equation, you just work out this one. See here, from this one 6.6, and if you take this one, cancel it here, this one you can cancel like 3 by 2 here. So once you are going to use this one as 3 by 2, 2 and 2 will be cancelled here, and 9 into 3 27, 27 here is into zero point 0.2 here is 0.54 will come, take a root of this one, and then you just cancel everything. So what you are going to have here is 0.54. if you are taking a root and multiply over here, so what you are going to have here is 10 power minus 9. From this one, if you simplify here, so what you are going to have here is 2.8 into 10 to the power minus 9 meter, which means so what they have given here is if the lambda value, lambda minimum, which should be greater than this value, that is a 2.8 nanometer, which is greater than this value, so that what happen here is the emitted electron which should have a maximum kinetic energy. So answer in this case, one here is a old question paper problem. The wavelength of electron lambda e and the wavelength of photon having a same energy are related to what relation with this. So one is about wavelength of electron, one is about wavelength of photon. So wavelength of electron we can define with the help of a de Broglie wavelength. So I just mentioned as a de Broglie wavelength, lambda is equal to h by p. Now this one, in this case, lambda of E, that is about wavelength of electron here, is h divided by square root of 2m, and having a energy they are mentioned as E, right? See from this one, so both are having a same energy. From here h is constant and even mass of electron is constant, so lambda it's mainly depends on directly proportional to square root of E, or even you can mention this one, lambda E square is proportional to 1 divided by capital E. This is one about uh, wavelength of electron. Next one, de Broglie wavelength of photon here. See this one, lambda of P is equal to hc divided by E. See, this is about a photon energy. Hope you know about this one. Photon energy E is equal to h nu, nu is equal to c divided by lambda. From here, lambda is equal to this one, nu is equal to hc by lambda, right? Lambda is equal to hc divided by E. So this is the concept. So based on this one, so the photon here is, so I just mentioned here, lambda is proportional to, because Planck constant, c also velocity applied, both are constant here, so lambda is proportional to E. See from this one, in this case, see from this one, find, compare the relationship between these two. So lambda of proton, so that one directly proportional to lambda of electron square. So answer in this case, to the end of the section. See, deep Broglie wavelength, there are a lot of problems that I couldn't finish in one presentation. I will take one more presentation where I am going to mention some of the important problems on deep Broglie wavelength. The maximum I am concentrating on the problem which was asked in examinations. All are old question paper problems that I am going to discuss. Maximum I am just concentrating on this one. You just have an idea. Just have any doubt, you just pass your doubt on the comments. Thank you.